Namaste. The World Space Week is the largest annual space event across the globe. It is on 4th of October 1957 that the first artificial satellite Sputnik 1 was launched into space by the USSR. It is on 10th of October 1967 that the Treaty on Peaceful Use of Outer Space was signed by the spacefaring nations. Connecting these two important milestones, the World Space Week is celebrated world over, for which ISRO, the National Space Agency of India, takes the lead role in the subcontinent. Today, we are fortunate to have with us distinguished space scientist and Director Liquid Propulsion System Center, LPSC, one of the lead centers of ISRO. Dr. V. Narayanan, a renowned technologist with remarkable contributions in development of liquid propulsion systems for the Indian space program, is a leader par excellence. Welcome, sir.
Thank you, Abhilash Narayanan. At the outset, my greetings to all the viewers as we celebrate the World Space Week 2022 in a big way after a restricted events during the last 2 years due to COVID pandemic 19.
Sir, this year's theme for World Space Week celebrations is space and sustainability. I feel we can start our discussions with your reflections on the theme with a specific focus on sustainable development, how it is achieved through Indian space program.
The theme space and sustainability focus on achieving sustainability in space and sustainability from space. In any sector, you may appreciate sustainable development is the need for ensuring sustainability. The United Nations had identified 17 sustainable development goals for its Agenda 2030. The important ones are concerning with poverty and hunger, health and well-being, quality education, clean water and sanitation, economic growth, gender equality, reducing inequality, good education, participation, climate studies and so on. It is in this context, I strongly believe the space program can contribute significantly on all these 17 agendas. Our Indian space program, as envisaged by the great visionary leader Dr. Vikram A. Sarabhai, focus on harnessing the space technology for the national development. In fact, from the time Indian space program was started in the year 1962, our aim was, rather our priority was not competing with other countries. Our priority was bringing the advanced space technology for ensuring safety and security of the common man and ensuring quality life of the common man of this country. To this effect, I strongly believe the sustainability is part of our system. In fact, to bring the benefit of space technology to the common man and for the national development, we need to have satellites and we have to develop launch vehicles for placing satellites in the orbit. And also we have to have ground segments for bringing the satellite data and processing the satellite data and ensuring the application for the common man. In fact, from 1962 onwards, we have concentrated on the development of all these three sectors simultaneously, and today we have reached to a level we have contributed for the growth and development of this country.
Sir, having touched upon the three major elements of a space program, can you please summarize how the launch vehicle development happened in ISRO?
In fact, I think most of the audience will be knowing we started the Indian space program in 1962. It was in the year 1963, exactly it was 21st November, we had a tiny rocket launch from Tumba Equatorial Rocket Launch Station, which is located close to Thiruvananthapuram. From there, we have come a long way. In fact, ISRO has developed a host of Rohini sounding rockets. In fact, more than 3,500 Rohini sounding rockets we have launched, and we have also generated 5 generations of satellite launch vehicles, which includes the SLV-3, Augmented Satellite Launch Vehicle ASLV, Polar Satellite Launch Vehicle PSLV, the GSLV and GSLV Mark III. If you see the payload carrying capability of our vehicles, the first satellite launch vehicle SLV-3, which was successfully launched on 18th April 1980, carried 40 kg to low Earth orbit. From there, we have built the capability. Today, our GSLV Bahubali rocket can carry 10,000 kg to LEO or 4,000 kg to GTO. That is the type of quantum jump what we have achieved in the launch vehicle area. Till today, from the first launch, successful launch 1980 to till today, we have accomplished 84 missions, launch vehicle missions. And towards this, lot of host of technologies have been developed. For example, the technologies like solid propulsion, liquid propulsion, cryogenic propulsion, aerodynamic systems, heat transfer studies, avionics development, structures development, and launch base infrastructure development, and so much developments have taken place in the launch vehicle area. And today, we are very comfortable. We are having 3 operational vehicles through which we have accomplished very important missions, like launching, placing 104 satellites in a single orbit. I think India is the first country which placed more than 100 satellites first time successfully in the orbit. And using our vehicle, we have accomplished interplanetary missions like Chandrayaan 1, Chandrayaan 2, Mars orbiter mission, and so on.
That's great, sir. India is really proud of ISRO. To continue this, what are all our future launch vehicle plans?
Currently, we are working on improving the GSLV Mark III payload. You all know the current capability of GSLV Mark III is to carry 4,000 kg payload to GTO. From that, we are going to enhance the payload capability above 5,000 kg to GTO. For accomplishing this, 2 major developments are taking place. One is a liquid oxygen kerosene based 200 ton thrust semi-cryo engine development is going on. Second thing is a C-32 cryogenic stage development. These are all the 2 developments, major developments are taking place. As most of the viewers know, very recently we have accomplished the small satellite launch vehicle mission. In fact, towards that we have developed lot of technologies, and this vehicle is capable of placing maximum 500 kg satellite to low Earth orbit, and in 2 to 3 days, based on the demand of the customers, we will be in a position to get ready for the launch and we can accomplish the mission. We are also configuring a heavy lift launch vehicle to have a capability 7.5 ton to 12.5 ton GTO payload capability. Towards this, the lot of experimental studies are initiated, and another important thing is the low cost access to the space, and we are also working on the reusable launch vehicle systems, which will reduce significantly the cost of launch. And we are working on multiple technologies like reusable launch vehicle technology, air breathing propulsion system, miniaturized avionics and inertial system, and so on.
Coming to the second major element, sir, the satellites. Can you please portray the development of satellites launched by ISRO?
No, in fact, the first satellite we launched was the Aryabhatta satellite. If I am correct, it was a 360 kg mass, and it was launched in the year 1975. Subsequently, we developed the experimental satellites like Bhaskara and Apple. From there, today we have come a long way, and we have designed, realized and developed different varieties of satellites for communication, remote sensing, navigation and scientific missions. Till today, to our credit, we have accomplished 116 satellite missions. Also, we have placed 342 satellites of 34 countries in the orbit. Now, coming to the satellite, it is a very complex technology. In fact, lot of technologies related to satellites, payloads, its propulsion system, its structures and power, lot of things we have developed. In remote sensing area, we had realized during Bhaskara time the payloads with optical payloads with 1 kilometer resolution. Today, we have successfully realized the payloads with 0.28 meter resolution and successfully flown the satellites. And in the optical payload area, we are in par with any other developed country in this technology. Now, to enable us to get the data, satellite data during all weather conditions, we have also developed microwave remote sensing payloads. Now, if you take the satellite mass in 1980, when we successfully launched the SLV-3, we had a payload of a satellite mass of 40 kg. From that, during the last 4 decades, we have got quantum jump. Today, we have the capability of realizing 6000 kg payload. In fact, the GSAT-11 high throughput communication satellite we have realized with 6000 kg and we have successfully placed in the orbit. Now, with respect to life of the satellite, it used to be 3 years, 4 years those days, but now we are having a quantum jump. Our satellite life, some of the satellite life today is 15 years. It nicely gives the performance. With respect to the power systems, that is one of the capability of the satellite. We had quantum jump from 6 kilowatt power with 42 volt system 2. Today, we are having capability up to 20 kilowatt and 70 volt power system. Till today, we have realized variety of spacecrafts for telecommunication, television broadcasting, remote sensing, navigation, scientific applications. We have flown almost 116 satellites and 342 satellites of 34 countries. In the satellite area, I will say today we have reached a level of great level of maturity. I am extremely happy to report that today we have 46 spacecrafts in orbit serving the common man of this country.
Definitely, our viewers will be interested to know that what benefits these satellites would give an average Indian man. Can you please elaborate?
No, in fact, I will say we have placed variety of satellites for different applications. Now, if you see, we have contributed significantly in the area of communication, resource management, navigation. In addition to these major functionalities, we have also contributed in the area of teleeducation, telemedicine, identifying potential fishery zone and scientific missions. Just to give few examples, if you take groundwater mapping, the success rate before the space program was less than 60%. Today, with the satellite data, the success rate has increased from 60% to 95%. Now, another one area is the crop production forecast. In fact, we are in a position to predict the crop production capability, and today we are having capability to predict 15 crops, and already ISRO has set a target to increase this capability to 30 crops. Another one area I will tell, potential fishery zone identification. In fact, through this scheme itself, per year we are getting almost 37,000 crore additional revenue by increasing the catch of fish, by reducing the search time, by reducing the travel and thereby saving the fuel, and this is another important area. Now, disaster warning and management is another important area where significant contribution is made, and in fact, I will tell you the national disasters whatever used to happen in the earlier days, we used to lose lot of our own brothers and sisters, but then today we have come a long way and the losses are very negligible. And another important application, recently we have placed a set of navigation satellites. Through that, significant contribution we have made. One application I will explain. You know, in India we are having 8,815 trains. Today we are in a position to track 2,800 trains on real time basis. Not only trains, even automobiles we are having tracking system. In the coming years, surely all the vehicles and all the trains will be in a position to track. Another important application is the mobile and internet connectivity. In fact, I will tell you 20 years back, to make a phone call to another town or city, we have to wait so many hours booking the trunk. But today, really revolution is made because of the satellite communication, the mobile and internet connectivity, lot of revolution is made. But even with this type of development, if you see, approximately 25,000 villages are yet to get to the mobile connectivity. In fact, the government of India is working towards this area to have 100% villages to have mobile connectivity. Now, we have got a important citizen portal called Bhuvan, and we have stored lot of national mapping. You know, approximately 10 million people per day are visiting that site and getting benefit out of it. Remote sensing data dissemination is another important area. Today, I am happy to report to the audience that almost 7.5 lakh data products are distributed per year, and coming years these numbers are going to increase multifold.